Welcome back to the second installment of this series. Here I would like to explain to you the instrument that we use to perform our research. So as many of you have likely experienced, there is a thick layer of air pollution that tends to get trapped in the San Joaquin Valley, where many of you live. And this is a huge mixture of air pollution from many different sources like vehicle emissions, or cooking, or agriculture, or different industrial processes. And each of these sources emits pollution that has different characteristics, different size of particles, and different composition. So if we can go into this big mixture and we can measure the composition and the size of individual particles one by one, then we can determine what source they came from. And that's exactly what we do with this instrument. It is called a single particle mass spectrometer, and what it does is it measures the size and the composition of individual particles, and it does this one by one in real time. And the first thing we do is we use what's called a Nafion dryer, and this removes all of the water from the particles and the air. Then we have dry particles that go through this tubing and enter this valve. And this is a 9-position valve, and it lets us direct the flow into one of 9 differently sized orifices. And the size of the orifice determines the flow rate through the instrument. And this flow rate, in conjunction with something called a critical orifice down here, determines what size of particles get focused into a particle beam. So this particle beam then comes down into what we call the source region, which is here. And usually on the bottom we have lasers. These are high-powered lasers, 193 nanometers UV. They're 20 millijoules per pulse. And the laser beam shoots this way. It hits a mirror, reflects the laser beam up this tube, and it meets that particle beam here in the source region. They're collinear counterpropagating, and as soon as that laser hits that particle explodes. It explodes into all different kinds of ions. And in the source region we have 2 accelerating plates, they're called, and they're held at different potentials. And this potential provides the force that accelerates these ions down what's called our time of flight tube. This is our time of flight tube right here, and the amount of time it takes one of these ions to travel down the time of flight tube to our detectors at the end determines the mass of that ion. And from the mass of that ion we can determine exactly what that ion is.